Hello, everyone, and welcome back. So we're looking at polynomial operations, and we're talking about multiplication of polynomials, part one. So part one focuses on the three important products where we're gonna talk about looking at the square of the addition of two variables, the square of the subtraction of two variables, and then looking at their difference. So over here, when I'm looking at this, okay, so when I'm looking at this over here, a plus b squared, right? What I want to notice is that this is basically saying that I have two of them, right? If I say 2 squared, that's saying 2 times 2. And if I have a plus 3, a plus b squared, that means I have two of them. So a plus b multiplied by a plus b, right? So that's what's going on here. It's saying that I'm multiplying the addition of a plus b squared, so basically twice. So what we want to use here is we want to use the distributive property in order to calculate this together. So I multiply this with this with this, and then as such. Now, when I do this, let's do it in two different colors. So when I do a multiplied by a, I get a squared. A multiplied by b, I get plus ab, right? And then when I do b multiplied by a, I get plus ba. And b multiplied by b, I get plus b squared, correct? All right, so let's see what we get when we simplify this. Well, when I simplify this, I get a squared plus, recognize that this says exactly the same thing as that, because 2 times 3, for instance, imagine a was 2 and b and 3 was the b. If I write it as 2 times 3, that's equal to saying 3 times 2, right? So AB is equal to BA. So technically, it's like I have AB plus AB, right? So how many ABs do I have? Yep, exactly like you said, I have 2 ABs. Okay, so I have technically a squared plus 2ab plus b squared. Okay, all right. Now let's do the second important product, which is the subtraction of the square of the subtraction of two variables, or the difference of two variables. So over here we can see then that if I use if I use distribution, so if I multiply a with a with b, and then I go I do b with b, b with b, b with a, and b with b. So let's do this together. So a multiplied by a, this first one, a multiplied by a, that's a squared. A multiplied by b, this is ab, but recognize that b has a negative, so negative ab. And then negative b, whoops, let's do it in blue. Negative b multiplied by a, that's negative ba. And then negative b multiplied by negative b. So negative b multiplied by negative b, this is like saying negative 2 times negative 2, for instance. That is equal to a positive 4, okay? So over here, we recognize that negative b times negative b, that's going to be plus, and then b times b, that's squared, b squared, okay? All right, so I simplify this, and I can notice that same idea over here. This is negative ab, so it's like saying negative 3 times 2, negative 3 times 2. Well, they're exactly the same thing, so it's like saying negative 6 minus 6, that's negative 12. So what I did here is we just recognize that because they're exactly the same thing, when I say negative AB, negative BA, I can think of it as negative AB, which is equal to negative 2 of those ABs. Okay? All right, so let's do this together over here. So we have a squared minus 2ab plus b squared. Okay? All right, let's do the next important product, which is multiplying the sum and difference of two variables. So here's our sum, here's our difference, and we're multiplying them. So again, we're gonna use distribution. First term with first term with second term, second term with first term, second term with second term. All right, so what do we get? We get a times a, that's a squared. A times b, that's plus, and b is positive, so plus ab. Negative b times a, that's negative ba. And then negative b negative b multiplied by positive b, that's negative b squared. Okay. All right. Now, again, like we said, the AB minus BA is the same as saying AB minus BA. Sorry, minus AB, because flipping their order doesn't matter. They both mean exactly the same thing. AB is equal to BA. Okay. All right. So then this gets 0. So we end up getting A squared. These cancel out. So A squared minus B squared. Okay, which is actually a special form, which we call the difference. This is difference of squares. And these two, and these two are called perfect binomials. Okay, it's just nice to know some key terminology here, but you don't have to memorize this. You just need to know how to use it. Okay, so okay, so I'm just gonna get rid of that. Just recognize that the ones that I kind of curved like that, these are perfect binomials, okay? All right, so what are the rules that we can pull out from here, okay? So rule number 1 about these 3 important products is that when I'm talking about the square of a binomial, okay, so square of a binomial, whether it's addition or subtraction, okay, so a plus b squared. So example, a plus b squared, or when we did a minus b squared, okay? So when I do these, when I do the square of a binomial, what do we notice? We can see that the answer is the square of the first, okay? So square of first term, and then plus, okay, so the first term, this is, so the square of the first term plus 2 times first term and second term. First term multiplied by, how about that? Okay, first term multiplied by second term. And then plus second square of second term. Okay. So what is going on here? This is when we're doing a plus b squared. I take the square of the first term, so a squared. I add 2 times the first term multiplied by the second term. And then I add the second term squared, okay? And when I do the subtraction, it's pretty much the same, right? So when I do the difference of squares over here, I do pretty much the same thing. I just, sorry, not difference of squares. When I do the square of a difference of variables, I get the same thing. So I get square of first term, right? So a squared minus, the only difference is the subtraction over here, minus 2 times this over here, the first term multiplied by the second term. And I add the square of the second term. So the only difference between these is basically that subtraction that we just talked about. This over here is the only difference between doing the square of a sum and the square of a difference, okay? So this is important to recognize because these three important products, when I see them, this is kind of a shortcut to getting to their final answers over here. Okay, so what we say is that this is equal to this is equal to that, and this is equal to this difference of squares over here. Okay. All right, everyone, that's it for this section. I hope that helped, and I'll see you in part 2. Bye.